Here's our next example of computing the radius and interval of convergence of a power series. As usual, we'll start by finding the center, so we note that if we plug in x equals 0, we get 0, so the center of this power series is x equals 0. Next, we're going to start with the ratio test, so we get limit n goes to infinity, absolute value, an plus 1, so x to the n plus 1 over n plus 1 factorial over x to the n over n factorial. So this gives us limit n goes to infinity, so that fraction on the bottom flips. So we're going to get x to the n plus 1 times n factorial over x to the n times n plus 1 factorial. So this gives us limit n goes to infinity. The x to the n plus 1 over x to the n, so this just simplifies to x, and we have absolute value, so absolute value of x. And then remember how our factorials work, so we get n factorial. N plus 1 factorial just means n plus 1 times n factorial. So our n factorials cancel, and we get limit n goes to infinity, absolute value of x over n plus 1. Now as n goes to infinity, absolute value of x is just some number, so this gives us some number over n plus 1. And as n goes to infinity, this goes to 0. So our limit is equal to 0, which is less than 1, for all values of x. So no matter what x is equal to, the limit is equal to 0, which is less than 1. So this tells us that our series converges for all values of x. So no matter what x is equal to, the limit is 0, which is less than 1, so our series converges for all values of x. So on our picture, our series converges no matter what x is equal to. And when our series converges for all values of x, we say that our radius of convergence is infinity, and our interval of convergence is minus infinity to infinity. So this one converges for all values of x, radius of convergence is infinity, interval of convergence is minus infinity to infinity, and again this happened because our limit with the ratio test which was 0, which is less than 1, for all values of x.